So in the last video, we looked at how our reciprocal trig functions related to the curves of sine x, cosine x, and the tangent of x. So now we're going to look at these new trigonometric definitions in more detail. So the first one we're going to look at is the cotangent of x. And the cotangent of x is related to the tangent of x. They're the only functions with the letter t, so that's a good way of remembering it. And we abbreviate the cotangent of x to COT, so the cotangent of x equals 1 over the tan of x. Now we know that tan of x equals sine x over cosine x from Nat 5. So we can say that the cotangent of x is equal to the cosine of x over the sine of x. So it's the inverse of the tangent function. So because it's the inverse of the tangent function, using our rules of indices for moving a denominator, we can also write this as tan of x to the negative 1. Now, we cannot confuse this with the arctan of x, which is the function we use for working out the missing angles when we're using the tan ratio. Now, if we know that the cotangent of x equals 1 over tan of x, then it makes sense that we can also say that the tangent of x equals 1 over the cotangent of x. And again, a good way of remembering this is that we've got t's in our related functions, the reciprocal functions. Now, the secant of x, I've highlighted the s because it's related to the cosine of x. And it's abbreviated to SEC. So the secant of x equals 1 over the cosine of x. And therefore we can also say that the cosine of x is equal to 1 over the secant of x. And this time it's opposite letters that are our reciprocal functions. So the secant is related to 1 over the cosine, and the cosine of x is related to 1 over the secant of x. Our final reciprocal function is the cosecant of x, and it's related to the sine of x, and it's abbreviated to CSC. And it is equal to 1 over the sine of x. And therefore we can say that the sine of x is related to 1 over the cosecant of x. Now sometimes you will see this referred to or abbreviated to cosec of x, but normally in trig we like to have 3 letters, so CSC is more usual. And you can see if we highlight the C and the S are showing the relationship between our reciprocal functions. So let's use our new reciprocal functions to help us rewrite the following without fractions in its simplest form. So we've got sine x over cos squared x plus cot 2x over cot x. Now, the first thing we want to do is we want to try and extract our known trig functions. So if we split that cos squared x on the denominator of the first fraction into cos x times cos x, then you can see that we're going to get our tan x function. So I'm going to rewrite the numerator as sine x multiplied by 1, and I'm going to rewrite the denominator as the cosine of x multiplied by the cosine of x. And for my second fraction, I'm going to rewrite that as cot 2x multiplied by 1, and I'm going to write my denominator as 1 multiplied by the cotangent of x. So my sine x over cosine x is going to give me tan x, or the tangent of x. My 1 over the cosine of x is going to give me the secant of x. And for my second fraction, I'm going to leave my cot 2x as it is, and my 1 over the cotangent of x is going to give me the tangent of x. So I end up with tan x multiplied by sec x plus cot 2x multiplied by the tan of x. Now I want to take out my highest common factor. So my highest common factor is tan x. And so that means that my final answer is going to be tan x, or the tangent of x, multiplied by the secant of x plus the cotangent of 2x. Now the second one I want to rewrite without fractions is this one here, which is 2 cos squared x minus 1 over sine squared 2x. Now, I need to remember my trig identities from higher. So my trig identities were sine 2x equals 2 sine x cos x, and then I had my cos 2x equals cos squared x minus sine squared x, but I could rearrange that to be 2 cos squared x minus 1, or 1 minus 2 sine squared x. So my numerator here is giving me one of the variants of cos 2x. And then I'm going to do what I did in the last slide. I'm going to split that sine squared 2x into 2 sine 2x's. So I know that my denominator is going to become cos 2x, and we're going to multiply that by 1, and then I'm going to split my sine squared 2x into sine 2x multiplied by sine 2x. Now, my first relationship here, I've got cos 2x over sine 2x, so that's the inverse of my tan 2x, so it's going to be the cotangent of 2x. So the cotangent of 2x. And then I've got my 1 over sine 2x, and I know that 1 over sine x would be the cosecant of x, so therefore 1 over the sine of 2x is going to be the cosecant of 2x. So I'm writing that as CS simplified in its simplest form. Now, the other trig identity that we need to remember going all the way back to Nat 5 is that cos squared x plus sine squared x equals 1. And if we rearrange that to get cos squared x equals 1 minus sine squared x, we can derive that sec squared x is going to equal 1 plus tan squared x. And we can rearrange that to get tan squared x equals 1 minus sec squared x, which is another useful one for remembering when we're doing rearranging.